Hi. Everyone say hi.
Hi.
There you go. So now those people that are absent that have to watch it have to listen to that part first. So 1.7, our last lesson on Chapter 1 material dealing with quantitative variables. We're going to talk about another graphing technique. And you guys have done versions of this in Algebra 2. And I know I had some of you in Algebra 2, so I know you've seen a lot of this stuff. But notice how it says box plots, and in parentheses it has modified, because we'll show you how to actually draw a modified box plot that actually puts the outliers as separate points in the box plot. And of course here it says the 5-number summary. So again, as it says here for a definition, a box plot is just simply a visual way of displaying what we call our 5-number summary. So a basic box plot with no outliers will have the inner quartile range set up as a box where the endpoints of the box are Q1 and Q3. Somewhere in between Q1 and Q3, you have a line that signifies your median. Now notice how I'm not putting it right smack dab in the middle. I'm doing that on purpose because the median's not necessarily smack dab in the middle. It's just saying 25% of your scores are in between these two values, and 25% of your scores are in between these two values. Then you also have your minimum value and your maximum value. So what we've just gone through basically here is some of the steps when graphing it. So you actually have your 5 steps here. One of the things that's not done up top that you should always do when constructing a box plot. It says draw a horizontal or vertical measurement scale. Meaning, if I'm talking about, say for instance, one of the problems dealing I think with stem plots that we did a few lessons ago, dealt with, it was like Algebra 2 test scores. So what you could do is down here, you label your variable. So it might be test scores. And if we remember, those test scores went from like 16 to 50, so I could start to make my number line 10, 20, 30, 40, whoops, and 50. So that's basically step 1. Now, it says draw a horizontal. You can technically do it vertical. One of your CFU problems you will do today will actually have them drawn out for you, and they're going vertically instead of horizontally. So just like many of your graphs, you can flip the axes. So just like I did before, you want to construct a rectangular box whose left edge is the first quartile and whose upper right edge is the third quartile. So just like I did before, maybe our test scores in Algebra 2 went from, say, roughly like 32 to 44. So I'm going to write the numbers on here just so that you see them, but you're not required to, okay? Because you have a scale below that might signify it for you. Say the median was 40. So I could put a line here for the median at 40. So that's step 3 where it says draw a vertical line inside the box at the location of the median. Then what you do is you're going to do your whisker pieces. However, say for instance the high score was 50 and it's not an outlier. You can just draw your end of your whisker there. But say for instance that score of 16 was actually an outlier. Okay? And technically it wouldn't be. So let me do it this way. Say if these were my lowest test scores, 10, 16, and 22. Okay? Totally making up those data points. Remember how we do outliers? What's the first thing I have to do to find an outlier?
Find the IQR.
Okay, got to find IQR. My inner quartile range of my made-up data here is how much? 12. 44 minus 32 is 12. Now, what do I have to do with that value?
Something.
Multiply by what?
1.5.
1.5. And I get 18. So I know that 44 plus 18 much bigger than my highest 50. But when I do my low end, what's 32 minus 18? 14. So now, do I have any data points less than 14? 10. So what happens when I do my box plot is I'll put a dot here or signify a point at 10. Now the question is, where does this whisker still go to? Well, it goes, according to our information, to the largest or smallest observation in the data set that aren't outliers. So 16 would be where this end of that whisker would go. So that's always the hardest part to find out.
Isn't it 20? 32 minus 12 is 20.
But it's minus 18 because you gotta go 1.5 times the interquartile range.
Okay.
So you got a minus 18, not 12. Yep.
Alright then.
So that's why we're going, the imaginary kind of borderline that separates outliers and not is actually at 14. So, now, that's if you have to do one by hand. We will use our technology quite a bit, okay, to do these box plots. So you should all have your calculators out, and we're going to do this example here together using our technology to graph our box plots. So the first thing we have to do, other than read the question, is we'll be entering in some data. So let's read the question first. It says a Consumer Reports article on peanut butter. Peanut butter.
Butter chocolate.
Okay? Reported the following rating scores on various brands. So, Consumers Reports is a magazine that actually rates all sorts of products. Every month they come out with a magazine and they will rank like the best cell phones, the best, tablets, the best computers, the best peanut butter. Okay? In this case, and they broke it down by creamy peanut butter brands and crunchy peanut butter brands. Okay? So it says construct a modified box plot. Modified means showing the outliers. For each data set, noting the important features of each plot. When they're talking about that, that means we're going to talk about socks. Okay? Shape, outliers, center, spread. Similarities and differences in the two data sets. So, right now in your calculator, we need to enter these two data sets into list 1 and list 2. Now, here's the nice thing. At least for me, I have them in my calculator. I'm going to give you a little bit of time to do so. So when you pull up your calculator, wow, I got a whole bunch of stuff going on here. Yep, I'm kind of giving my answer away, aren't I? Okay, come on. There we go. Finally got the screen to clear. But to enter in your data set, stat, go to edit, type in, okay, the creamy peanut butter scores into list 1, type in all of the crunchy values into list 2. Now, the thing to note is that the lists, and this is okay, if you notice there was one more creamy peanut butter score than crunchy score. That's okay. When comparing these two distributions, they don't have to be the same size. Later on when we get to chapter 3, when we compare two pieces of data and trying to see the direct relationship between their values, it will matter. Okay? But for right now it doesn't, because we're looking at crunchy scores or creamy scores compared to crunchy scores. We'll give you about another 30 seconds or so. Hopefully you'll get all the scores typed in. If you got a second, double check just to make sure you typed them in correctly. I I would say, because I enter in lists into the calculator all the time, since I teach the statistics course and the AP stat courses, I make mistakes probably about 1 in every 10 lists I enter in. I'll just type in, 32 instead of 42, or I'll accidentally put 2 data points on the same line, and it throws it off.
I don't know why.
All right, just by a show of hands up high, anyone needing any more time? All right, since we are good to go, I want to create these graphs on my calculator. Okay? So to do so, we are creating what's called a stat plot. Okay? So on your calculator, where in the world are stat plots? Well, we know how to graph lines by going to the y equals. Right up above it, you'll see either, for my calculator it's blue, but depending on your calculator, a lot of you that have the yellow ones or just a different color, it'll say stat plot. So you hit your second key and your y equals, and you're going to go to stat plots. Now, more than likely right now, either all of your plots are off or just the first one is on. We're going to eventually turn the first one on and the second one on, okay? Because I still have mine here from last block. But once you get to this part of the menu, select the first one where it's highlighted. So just go ahead and hit enter. So now what you want to do is move your cursor here so that on is highlighted and hit enter. It won't move the cursor, however, it might move the cursor from off to on. Once you do that, hit the down arrow. You want to highlight the graph that we're trying to do, and we're trying to do the modified box plot. Right now, my cursor is on a scatter plot, which is something we do in Chapter 3. Here's a histogram. You can actually do them on your calculators. We don't show you how to do them in here because it takes a lot of time. You're almost better doing with small amounts of data than by hand faster. But I want this one highlighted. You cannot get to it by hitting the down arrow, which many of us want to do. You actually have to go right or left, and that's how you get down there. But you want to put your cursor on that one and hit enter, so that when you hit the down arrow, it's highlighted. So right now I have it on, and I have the modified box plot selected. Are we good with those two? All right, next one is, what list do I want it to graph? Well, since this is my first stat plot, I'm going to ask it to graph list 1. So mine says list 1, but if yours doesn't, second 1 will plug in list 1. Second 2 is list 2. Second 4 is list 4. Okay, and so forth. So now, once you have that, you guys go ahead and hit graph for a second. I'm going to do something with mine, because I'm going to turn number 2 off.
What?
Okay?
Press graph?
So now, hit the graph key, and my guess is for 90% of you, nothing showed up.
Yeah.
Or maybe a little part of the graph showed up.
I got some free lines.
Okay? Or we got some free 3 lines. Okay? So, yep, which is part of your box plot. Okay? Now, here's the thing. Everybody probably has different issues. I'm going to try to get most of you on the same page. If, okay, you have nothing showing up but just kind of a blank graph or maybe something, the reason why you're not getting part of the graph is because your window's not set up. Okay? In those creamy scores, we probably had scores, I think, that go from like 22 to probably like 50, 60, 70, and your window's totally not set for that. So when we deal with statistics, the quickest and easy way to get your window to fit is you go to this zoom key, and if you actually scroll down to number 9,
Found it.
okay, you'll see this thing called zoom stat. You don't want zoom fit, you want zoom stat, because it will zoom in and fit all the statistics that you are asking the calculator to analyze into your window. So when I hit that, hopefully you get something like this to show up. So hold on for a second. Okay, I want everybody to do that right now. How many of you are still getting like an error dim mismatch? Okay, if you're getting an error dim mismatch, and this helps for people who are watching the video, go to your y equals right now. Make sure every single thing in here is cleared out. Okay? So, everything here has to be cleared out, and you need to sometimes go to the very bottom of it, because some students like to just throw their calculator in their backpack, they don't put their cover on it, and then as you're carrying your backpack, your keys are getting hit, and so it just does random stuff, and sometimes what will happen is you'll have a bunch of this stuff, I kid you not, in this area. And so now if I hit graph, guess what happens? I get this syntax error, right? So I can hit go to, and it will actually take me to it, and I can clear that stuff out, okay? So now, another reason why you could have an error dim mismatch, okay, is if I go back to my stat plot menu. So I'm going second y equals on my calculator. I gotta make sure the only plot that's on right now is the first one. So if you have other plots on and there's no data in your calculator for it, it's gonna give you an error. That's that error dim mismatch. It's not matching up to the information that you have. Is there anyone in here that's still having calculator errors? Please let me know. Are we good?
No, we're good.
We're good? Okay. Was it the y equals part for you?
Yeah.
Alright, beautiful. Took care of one of the reasons. Alright, so we got the first one done. So let's go to the second one. So go second y equals, go to stat plot. We're going to check out or pick number 2. We're going to turn it on. So notice how I actually had to hit enter on the on. I'm going to again go down and make sure that it's the modified box plot. Mine's already highlighted there. But I want it to be list 2. So second 2, mine's assigned that, but I'll do the steps you need to, second 2, to get it to say list 2. Now if I hit graph, does my second box plot just automatically fit in there nicely?
No.
No. So guess what we got to do yet again?
Zoom.
Zoom
How do you do that?
9. So zoom 9 fits it in there nicely. Wow, look at that one. What does that one have?
That one.
Ooh, has an outlier.
Can you go over the second one again? How do you get the second one on there?
Second y equals.
Oh, never mind.
Then I just go to the second plot, turn it on, choose the right graph, and make sure it's on list 2. If your plots are exactly the same plot, one of yours is, well, you've done it for the same list twice. So you gotta change one of them to be list 1 and one of them to be list 2. So I'm gonna go back to this graph part.
Wait, how do you get L2?
Second 2.
Oh, duh.
How do you get to the zoom? Zoom is right here,
It's lit.
top middle button, and then I just go zoom 9 because I don't like to scroll. If I know which command it is, you can hit the number and it will do that command exactly for you. So again, just to kind of note, maybe in your notes somewhere, zoom, or I should put it like this as a keystroke, zoom 9 fits your graph in the window.
I got 2 outliers, man.
So now, what I want to do though is draw what I see on my calculator and help myself out. So to help myself out, what I'm going to do is if I go back to my calculator for a second, what I can do is once I have the graphs there, you might be going, okay, that's great, but where are these numbers located? Right next to the zoom is the trace key. And what trace allows you to do is to hop around, not only the first one, but both box and whisker plots here. So if you look at list 1 here, what's really nice is there's your minimum. If I use my right arrow, it takes me to Q1, median, Q3,
Oh, that's so convenient.
maximum.
For no reason.
Now here's the nice thing too. Use your down arrow. It will jump to plot 2 for you. And then you can get all of those values. So what I'm going to do is I'm going to go away from this calculator. However, I need someone to give me the 5-number summary for plot 1. Not only the 5-number summary, but I need this number here and then the outlier. So, if someone would kindly read the numbers for creamy peanut butter. What was the lowest value?
22.
22? Then what?
36.
Thank you.
44.
Okay,
53.
yep.
58. Gotcha.
58?
Yeah, there's a 30.
Okay.
There you go.
So this is my 5-number summary for creamy peanut butter. We're going to do the same for crunchy because this is going to help me graph it. Now you could probably just do it right from the graph, but since I got to go back and forth, I'm writing them down. So 5-number summary for crunchy. What was the low?
40.
And then,
47.
thank you.
55.
Yep.
64.
64.
Okay.
86.
86.
Okay.
95.
95.
Okay. So I purposely put that 86 in parentheses because it's technically not one of the 5-number summaries. It's where the graph will go. It's the last data point that's not an outlier on the upper end. This 95 is going to be my outlier. Okay. So now I actually have to construct these graphs. So I'm going to make a number line.
Yes.
I have rating scores. For peanut butter. Oh, I hate it when it's not picking up. Sorry, it's not right in the center, so maybe I'll extend that out. So, if I look at both sets, my lowest score was 22 between the two sets, and my highest score was 95. So I'm going to start at 20 here and count by tens. 30, 40, 50, 60, 70, 80, 90, 100. So now, on the top half, just like it appears on my calculator, I'm going to have a box plot for creamy peanut butter. So, and then I'm going to do one for crunchy. Now our steps, you can graph it however you like, but according to at least the steps, we start with the inner quartile range. So we make a box between 36 and 53. So I come here at 36, go out to about 53, and I make my nice rectangular box. Then I drop a line for my median at 44. Then we can go to 22 as a low for one of the whiskers and 58 as the other whisker. Now, if you want, you can write the numbers on there. You're not required to. Just because it will make it a little bit easier for when we start to do some comparing, finding similarities and differences, it'll be nice to have these values. So now I'm going to do the same for crunchy. So this one starts at, 47 to 64. So I go 47 to 64. Draw my box. So 47, 64. Median was 55. So the lower tail goes to just 40. Now the upper tail goes to 86. And I have this outlier at 95. So we have our beautiful graphs. Now we need to use what we see to answer the question, which says, again, it asks us noting the important features of each plot and commenting on the similarities and differences of the data set. So when we're going to compare and contrast, we're going to talk about some of the similarities that they have with that acronym SOX. Shape, center, spread, outliers. I know it doesn't spell it in that way, but SOX is better as an acronym. I like to tend to do it in that particular order because that's how it kind of came up in the notes. So when we talk about shape, I know on the video, if you're watching this from home, you can't see what I have written on the whiteboard. But on my whiteboard, you will see keywords I look for shape. Skewed left, skewed right, symmetric. And then the other word bimodal, meaning does it have like two hills in it. You can't tell if something's bimodal from a box plot. That's the downside of it. You can't tell if there's really any major gaps in it other than maybe when there's outliers. Okay? That's the downside of it. But you can still start to see at least a little bit of the shape. It can be deceiving because one point can throw it. But if you start to look at the distances, the left side to the right side, is one side a lot longer than the other side. So if you were to look at creamy scores, would you say this is symmetric, skewed to the left, or skewed to the right? Okay, which way is longer? Is it longer from 44 to 22 or 44 to 58? Okay, that's 22 units long versus only 14. Okay, so I would say that creamy is a little bit skewed to the left. However, crunchy scores are definitely skewed to the right. 15 versus 40. Right? So that's one comparison that I could say. So I can start off by saying creamy scores are skewed to the left, while crunchy scores are skewed to the right. This, with the skewness going in opposite directions, that's going to suggest that crunchy scores are higher than creamy scores. This suggests crunchy scores are higher than creamy scores. Now, I've only talked about shape. I still need to talk about the other ones. So I'm going to talk about center. Since it's skewed to the left and one skewed to the right, I have skewness. We talked about it in yesterday's notes. If something is skewed, which measurement should you use? Mean or median?
Median.
Give you a hint. Look at the board. It kind of got arrows or lines connecting them. Should talk about median because outliers or skewness impacts a mean greatly. It pulls it and causes it to be vastly bigger or smaller than the median. So in our case, I'm going to compare the medians together. So which value has a bigger median?
Oh my god, that's only 145.
Crunchy. Crunchy has a 11-point higher rating than Creamy does. So I might say, whoops, I forgot the A in Creamy there. That's funny. So I could say Crunchy scores are 11 points higher than Creamy scores when comparing the medians. 55 versus 44. Now when I take a look at their spreads, I'm taking a look at their measurements of variability. Because they have one has outliers and they have skewness, standard deviation is not a good measurement of spread. Plus we haven't even calculated it out. However, interquartile range, the middle 50% of scores, or the range of the middle 50% of the scores, is a much better measurement when comparing spreads. So what I need to quickly do here is, up here, just calculate out the IQRs for each. So for Creamy, my IQR would be 53 minus 36, which is 17. And what is it for Crunchy? 64 minus 47, which is 17. So now what I can say is the middle 50% of scores for both distributions has a range of 17 points. I'll just put in parentheses, it's the IQRs. So I just want to talk about one more thing. So I've got shape, center, spread, just got to do outliers. Which one had an outlier?
Crunchy.
Crunchy. Crunchy has one high outlier at 95, while Creamy has no outliers again, suggesting that Crunchy ratings tend to be higher. Now, there are a few more things that I could note, but this is what I would be looking for if it asked you to compare and contrast. I'm going to ask you to talk about socks, okay? But I could, if I wanted to, I'm going to do this for a second. I know that some of you might still be writing, but I want to, I'm going to shrink it just a little bit so you can still see and I can look at the distributions. Now, if you were to try to make a good argument why one is better than the other, or one's getting better ratings than the other, well, you could say something to the extent of 75%, because this is Q1 and greater, so 75% of crunchy scores are higher than 50% of creamy scores. Okay? Or you could say 50% of crunchy scores, okay, are higher than 75% of creamy scores. So you could use some arguments there showing that, wow, over half of crunchy scores are better than 3/4 of creamy scores. Okay? So, which is another valid argument that you could make from these graphs. Alright, before we turn to the CFUs, questions that you have about doing box plots, the interpretation, etc., etc. Alright, I'm going to stop the video.